example on L hospital rule. Last lecture example that tan x minus x divided by x cube, x tends to 0. Okay, so limit x tends to 0. So if we have 0 by 0 form, so integrate derivative of this sec square x is what 2 sec x into tan x. Derivative of sec x is what sec x into tan x. Derivative of minus 1 is 0. Then derivative of 3x square is 6x. Then this becomes sec square x tan x, 2 by 6 means 3. And then again the derivative of this quantity is u into v root sec square x u, that is v, derivative of tan x is sec square x, plus v means tan x, derivative of sec square x is what 2 sec x into tan x. And then substitute x at 0, derivative of 3x is 3 by L hospital rule. Substitute x at 0. So we have sec 0, sec square 0, sec square 0, tan 0, 2 sec 0, sec 0, tan 0. And tan 0 is 0, but sec 0 is 1. So this 1 into 1 becomes 1 plus this quantity 0 divided by 3. So 1 by 3 is the answer. Next problem, limit x tends to 0, log 1 plus x divided by sin x. So log 1 plus 0 means log 1 means 0 and sin 0 is 0. So 0 by 0 form. So apply your hospital rule. Log sin x derivative is 1 by 1 plus x. And sin x derivative is cos x. And now if you substitute x is 0, the value of limit of numerator is 1 and cos 0 is 1. So answer is 1. So these are some problems on L hospital rule. Solve all the homework problem assignment depend on the L hospital rule. So next theorem is Taylor's theorem with Lagrange's form of remainder. So question is state the Taylor's theorem with Lagrange's form of remainder. So the statement is the proof is not included in our syllabus. So just statement, remember the statement of the Taylor's theorem with Lagrange's form of remainder. So let f be a function defined on the closed interval a plus h or 0x. Another notation is 0x such that f(e) and its derivatives of nth order, n minus 1th order, are continuous on closed interval a plus h. Function exists in open interval a plus h. Then there exists a real number theta is less than 1 and greater than 0, such that f of a plus h is equal to f of a plus h, f dash a plus h square by 2 factorial f double dash a, and so on, h raised to n minus 1 divided by n minus 1 factorial f raised to n minus 1 theta a plus f raised to n minus 1 a plus rn, where rn is what? The next term is what? H raised to n by n factorial f raised to n a plus theta. So this is the this Rn is called remainder after n terms and is called Lagrange's form of remainder after n terms. So this is the Taylor's theorem. So this Taylor's theorem is what? F of a plus h is f of a plus h f dash a plus h square by 2 factorial f double dash a. Next term is what? H cube divided by 3 factorial f triple dash. Next term is h raised to 4 by 4 factorial f raised to 4a, fourth order term. In this way, this is the nth term, h raised to n minus 1 divided by n minus 1 factorial f raised to n minus 1 f of a. Then Rn is this term. Okay. So this is the Taylor's theorem and is called Taylor's theorem with Lagrange's form of remainder. Then Maclaurin's theorem with Lagrange's form of remainder. So question is again state the Maclaurin's theorem with Lagrange's form of remainder. So just write a is equal to 0 and h is equal to x in the above theorem. Write a is equal to 0 and h is equal to x. So what is the statement now? F is a function defined on closed interval 0x such that f and its derivatives, derivative of n minus 1 order, are continuous on closed interval 0 1, and the function exists in open interval 0 1. Then there exists a real number theta function is differentiable. Function is right here f raised to n x, that is the function is differentiable in open interval ab, second condition, 0x. Then there exists a real number theta. Theta is less than 1 greater than 0, such that same statement, just write a as 0 and this a plus h. Okay. So f of a plus h. So write a as 0 and h as x. The second condition is what? F raised to n exists here, right? The function exists, f raised to n exists, that is the nth order derivative exists in the place of function, right? F raised to n means nth order derivative. F raised to n means what? The nth order derivative exists in a plus h in Taylor's theorem. So, right, in the place of function, right, f raised to n, that is the nth order derivative, exists in a plus h. So here is also, right, f raised to n, that is the nth order derivative, exists in 0 x open interval 0 x. So correction is at this place, right? In the place of function f raised to n, either write that n in bracket, that is the nth order derivative, exists in 0 x, and here is also the correction. The in the place of function, right, f raised to n exists in a plus h. Then what is the statement, right? In this statement, as a as 0 and h as x. So what do we have? Fx is equal to f of 0 plus x, f dash 0 plus x square by 2 factorial f double dash 0. Okay, so write a as 0 and h as x. So fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial, right, h as x, f double dash 0. In this way, we have the x raised to n minus 1 divided by n minus 1 factorial f raised to n minus 1 0 in the place of a, right, 0, f of 0 plus Rn, where Rn is what? X raised to n by n factorial f raised to n 0 plus theta x, because a is 0 and h is x. 0 plus theta x means theta x. So this is the Maclaurin's theorem with the Lagrange's form of remainder, and this is the Taylor's theorem with Lagrange's form of remainder. So just write a as 0 and h as x in Taylor's theorem. We have the Lagrange's theorem. The examples on this theorem: expand e raised to x by Taylor's theorem or Maclaurin's theorem, both are same, or obtain power series expansion of e raised to x. So write Maclaurin's theorem. The expansion is about 0, 0. So write Maclaurin's theorem. Fx is equal to f of 0 plus x f dash 0 x square by 2 factorial f double dash 0 x cube by 3 factorial f triple dash 0 and so on. So this is the Maclaurin's theorem. Fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 x cube by 3 factorial f triple dash 0 and so on. So now fx is e raised to x. The function for expansion is e raised to x, and therefore f of 0 is e raised to 0 is 1. Right, on right side the values of f of 0. Then f dash x is e raised to x. Then f dash x is e raised to x. Derivative of e raised to x is e raised to x. And then f dash 0 is e raised to 0, that is 1. Right, on right side here. F dash 0. Then f double dash x is again e raised to x, derivative e raised to x. And f double dash 0 is e raised to 0, that is 1. F triple dash x is again e raised to x. The derivative of e raised to x is again e raised to x. And the value at 0 is e raised to 0, that is 1. F fourth order derivative, right? 4 time dash, right? F raised to 4, x e raised to x is this, again 1, and so on. Substituting these values in equation number this star. So fx is what? E raised to x. Then f of 0 is 1, f of 0 is 1, plus x f dash 0 is 1, plus x square by 2 factorial f double dash 0 is 1, plus x cube by 3 factorial f triple dash 0 is 1, plus next term x raised to 4 by 4 factorial f raised to 4 0 is 1, plus so on. So the expansion of e raised to x is what? 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial in this way. So this is the power series expansion of e raised to x. standard power series expansion of e raised to x, or it's called Taylor series expansion, or it's called Maclaurin series expansion. Maclaurin's expansion. So next is expand sin x, or obtain the Maclaurin's expansion of sin x, or obtain the power series expansion of sin x and cos x. First problem is sin x. So by Maclaurin's theorem, we have fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f triple double dash 0 x cube by 3 factorial f triple dash 0 and so on. Suppose this is the equation start. Now the function for expansion is sin x, so fx is equal to sin x. Then f of 0, because here we have to substitute f of 0. F of 0 is sin 0 is 0. Then f dash x, sin x, derivative of sin x is cos x. And then f dash 0 is cos 0 is 1. Then f double dash x is minus sin x. And the derivative, the value at 0, f double dash 0 is what? Minus sin 0 is 0. Then f triple dash x is sin x, minus sin x, derivative is minus cos x. And the value at 0 is what? Minus cos 0, that is minus 1. And then fourth order f raised to 4x is derivative of cos x is minus sin x, so minus minus become plus sin x. And then the value at 0 is sin 0 is 0, and so on. So we have the value 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1 in this way. Substituting these values in equation number star, we get fx value of fx means sin x. F of 0 is 0 plus x f dash 0 is 1 plus x square by 2 factorial f double dash 0 is 0 plus x cube by 3 factorial f triple dash 0 is 1 is minus 1. Then f x raised to 4 by 4 factorial into 0, the value of fourth order derivative. Then plus next term is x raised to 5 by 5 factorial into 1 into 1. So I find here fifth derivative. F raised to 5x is what? Cos x. And so the derivative, the value at 0 is what? Cos 0 is 1. So write that term, x raised to 5 by 5 factorial, x raised to 5 by 5 factorial into 1. And then we have sin x is equal to x, this term x, then x minus x cube by 3 factorial plus x raised to 5 by 5 factorial. So we have the expansion sin x as x minus x cube by 3 factorial plus x raised to 5 by 5 factorial. Obviously next term is what? Minus x raised to 7 by 7 factorial. Then next term is what? Plus x raised to 9 by 9 factorial in this way. So this is the expansion of sin x. Similarly, the expansion for cos x, fx is equal to cos x. And therefore, we have f0 is cos 0 is 1. Then f dash x is minus sin x. Derivative of cos x is minus sin x. Then f dash 0 is minus sin 0 is 0. F double dash x minus cos x. Derivative of sin x is cos x. And f double dash 0 is what? Minus cos 0, that is minus 1. Then f triple dash x, derivative of cos x is minus sin x. So minus minus become plus sin x. The value at 0 is sin 0 is 0. Then fourth order, then f raised to 4x, cos sin x, derivative is cos x. And the value at 0 is cos 0, that is 1. Then fifth order derivative, right? Fifth 5 power of this f, x is cos x, derivative is minus sin x. And the value at 0 is what? Minus sin 0 is 0. If you find the next derivative, sixth order derivative, then it is minus sin x, derivative is cos x, so minus sin x, derivative is minus cos x. And then value we have the value at 0 is minus 1. So if you observe the values, 1 0 minus 1 0 1 0 minus 1 0 1 0 minus 1 0, in this way we have the value, and so on. Substitute these values in equation star. So fx, equation star is this. Fx is cos x. Then the value of f of 0 is 1. F of 0 is 1 plus x f dash 0 is 0 plus x square by 2 factorial f triple dash 0 is minus 1 plus x cube by 3 factorial f raised to 4 0 is 0. Then f triple dash x, here is f double dash x, f triple dash x is 0. Then x raised to 4 by 4 factorial f raised to 4 0, f raised to 4 0 is 1 plus x raised to 5 by 5 factorial f raised to 5 0 is 0. Then plus x raised to 6 by 6 factorial f raised to 6 0 is minus 1, and so on. So we have cos x as 1, this one, this will become 0. This minus x square by 2 factorial. This is the x raised to 4 by 4 factorial into 1 means plus, in this way. Okay. So next term, this term is 0, but next term is minus x raised to 6 by 6 factorial. So cos x is 1 minus x square by 2 factorial, this minus, plus x raised to 4 by 4 factorial. Next term is minus x raised to 6 by 6 factorial. You find the next term, and so on. So expand x into sin x. So sin x is this x minus x cube by 3 factorial, x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial, and so on. So x into sin x just multiply by x. So x square minus x raised to 4 by 3 factorial plus x raised to 6 by 5 factorial minus x raised to 8 by 7 factorial, and so on. So this is the expansion of x into sin x, or we can find this expansion of x into sin x by separate method. That is, apply this method, right? First Maclaurin's theorem, this theorem, then let fx is equal to x into sin x, and then find its derivative. First order derivative, second order derivative, third order derivative, fourth order derivative, and the values at 0. And substitute the values, we have this answer. So we can separately obtain the expansion of x into sin x by Maclaurin's theorem, or just write the multiplication expansion of sin x and multiply by x throughout. We have this answer. So similar method we can obtain the expansion of x into sin x. Okay, tan inverse x e raised to sin x. Okay, so third one is what? Obtain power series expansion of log 1 plus x. Log 1 plus x. So by Maclaurin's theorem, fx is what? F of 0 plus x, f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0, and so on. This is the equation number star. Now fx as a function log 1 plus x, and then value at 0 is what? F of 0 is log 1 plus 0 means log 1, and log 1 is 0. Then f dash x is what? 1 by 1 plus x, derivative of log 1 plus x. Then f dash 0 is 1 by 1 plus 0 means 1. Then f double dash x, the derivative of 1 by 1 plus x is what? Minus 1 by 1 plus x bracket square into derivative of 1 plus x is 1. Then f double dash 0 is minus 1 by 1 plus 0 bracket square is minus 1. Then f triple dash x, the derivative of this quantity. So f triple dash x is, this is the 1 plus x bracket raised to minus 2. This expansion is what? 1 plus x bracket raised to minus 2. And so this is the simplification. And so its derivative, next derivative is what? 1 minus 2. So minus minus become plus, this minus sign and minus sign. 1 plus x raised to minus 2 minus 1, that is minus 3. So the expansion, the simplification is right here, 1 plus minus 1 plus x raised to minus 2, and its derivative is what? Minus 2, 1 plus x raised to minus 3. And the value at 0 is what? Is 2, because 1 plus 0 raised to minus 3 is 1. Then the fourth order derivative, the derivative of this quantity is what? Minus 6, 2 into minus 3 minus 6. 1 plus x raised to minus 3 minus 1 means minus. So then value at 0 is what? Minus 6, and so on. You can find out the fifth order derivative, sixth order. And then log 1 plus x is equal to, that is, substitute the values in equation star. Fx is log 1 plus x, f of 0 is 0, plus x f dash 0 is 1, plus x square by 2 factorial f double dash 0 is 1, minus 1. X cube by 3 factorial f triple dash 0 is 2. Then the next term is x raised to 4 by 4 factorial f raised to 4 fourth 0 is what? Minus 6, and so on. So we have log 1 plus x as x minus 1 half x square, that is x square by 2. Then x cube by 3 factorial means 6. 2 by 6 means divided by 3. Minus next term 4 factorial is 24, and 6 by 24 is divided by 4. 6 4 are 24. So minus x raised to 4 by 4. Next term must be what? X raised to 5 by 5 plus x raised to 5 by 5, and so on. So this is the expansion of log 1 plus x. So these are the problems for homework. Expand tan inverse x, tan x, sin 2x, sin square x by root 1 minus x square, e raised to sin x, e raised to sin x into sin x, log 1 minus x. Okay. So these are the problems for homework. So in the same method, we solve these problems. So answers are given. That is, suppose fx is tan inverse x, then find f dash x, f double dash x, f triple dash x, and their values at 0. Okay, tan x, same problem, same method solve these problems. So we'll see the remaining problem on the Taylor's theorem and Maclaurin's theorem in the next lecture.